This was before digital, so I just dated myself. But after I got the film back, the pictures, I'm going through them, showing my wife, and I said, well, this is really a nice picture, but why did I take that one? Because I had forgotten the change. But this happens, that happened within about 3 or 3.5 hours. And a lot of it has to do with the traffic in the morning and the heating of the atmosphere as the sun's coming up. Is they have an enormous amount of pollution from vehicles because they don't have as much heavy industry as a lot of places do. Well, probably don't want to live there. I wouldn't want to live there anyway for other reasons, but that's a sign. That's not bad, except you still see this haze stuff. Look familiar? That's Korea. Wouldn't want to live there either. Because they have the same problems, only you're seeing it up in the mountains. And again, the obscurity. Well, maybe here. Not attractive. Unfortunately, that's where you live. That's taken from the Blue Ridge Parkway. Okay. Not a whole lot of difference, is there? This is probably, you certainly don't want to live here. This is probably one of the most significant events that has occurred, and it's been cited a number of times as the one of the top 100 greatest catastrophes for mankind. This occurred in 1952 in London, and it's referred to as the London Fog or the London Killer Fog. It was in the winter. There was a lot of coal being burned. You got an inversion. Formed a layer that trapped all that particulate and gases and everything else for 3 days. And this is what it looked like. You can hardly see some of this stuff. And this guy's breathing it. What's happening to him? Well, Paul talked about particle sizes, and it's referred to as PM, which means particle size in microns, okay? And it's really a measure of what's referred to as the aerodynamic diameter, which is in effect what the effective diameter is in the air, but it translates into the diameter of the particle. 10.5, and it's roughly grouped because they're distributions of these particles, and there are coarse particles and fine particles. Coarse particles tend to be that they refer to it as PM 10.5. Smaller particles, the ones that everybody's concerned about right now, are PM 2.5. Both of them have an impact, but on different parts of the respiratory system. So, if the radius is greater than 10 microns, then it's up in here. And the finer particle gets down into here and eventually down into the lungs. And when it gets down into the lungs, and you notice that this is less than 3 microns, so that PM 2.5 is what they're talking about. When it gets down into the lungs and it's a particle that's small, it can be absorbed into the body. And it goes everywhere. And basically, they've shown that there's an increase in the death rates associated with these kinds of particles. More recent work that was done by Schwartz, Joel Schwartz, who is a professor at Harvard School of Public Health, has demonstrated by taking a series of instruments, spread them around suburbs in the Boston area, that it isn't just the respiratory system that is affected. It's also the cardiovascular system. Because what they found was that when they had significant loading in the atmosphere of these particles, what they did was they correlated their measurements with the local hospital's emergency room visits. And for what purpose? Well, naturally, they saw asthma increase in asthma, respiratory problems, lung irritation, but they also found an increase in people coming to the emergency room for hypertension and heart attacks. And the correlation is very strong. So once these particles get into your lungs, they don't just affect the lungs, they go into the system, and they can affect other things. This shows the effect, which is pretty dramatic, of the London event. And you see there's smoke, sulfur dioxide, and you can't really tell. This is supposed to be blue, a light blue, but it doesn't come out that way. You can see the smoke hit a peak. And the sulfur dioxide, the smoke as well, and then lagging was the deaths, and it had this tail that was longer, and one might say, well, why? And the answer is that it takes a little while after exposure for these things to start to have their effects. So you're going to see it delayed relative to the peak of the event, and then it's going to tail off in terms of the response of the human physiology to that event. Okay, so how do we measure these things? Well, there are several ways we do it. Paul's talked about satellites. Jessica's alluded to that. Certainly the new National Climate Data Records Center will deal with satellite data primarily. They have a series of satellites that's called the A-Train, because it's led by Aqua, which is one of the satellites that, there were two of them that were put up, Terra and Aqua. Terra was primarily Earth-looking, land-looking. Aqua was primarily water-looking. But then there are other satellites with differing instrumentation, and they're synced so that they map the same portion and footprint on the Earth. Now, granted that the footprint size is different, but you notice that from the time that Aqua goes over to the time that the last one, Ara, goes over, it's only 8-minute difference. So you're really getting a snapshot of that swath through there. And from the data, people are now starting to be able to pull out air pollution events along that track. If we could do that with a fine enough granularity, then we'd be fine, but that's not the case. And, oh, by the way, these things are exposed to space conditions, so their instrumentation isn't stable. They age much more rapidly than it would if it were on the ground, because they're exposed to extremes in temperature. They're exposed to, particularly harmful to them, are high energy particles.